Yeah, it seems to be here. Okay. Okay, I think it's time. Okay. So, hello everybody. This is Luboš Pirkl from CFD Support. Welcome to the webinar on Turbomachinery CFD, which is a CFD simulation workflow for all standard rotating machinery. The test case for today that will be shown today here is Radial Turbine, a part of turbocharger from a car, for example, or airplane, a Radial Turbine. Yeah, so I hope everything works on your side, on my side. Just in case of any technical problems, feel free to contact us in the future and we will gladly answer all your questions or reminders. So we are open, so feel free to send us an email or call us anytime and we will tell you what we can. We will do our best. So today's webinar is going to take up to 1 hour. In the first part, I will show you how to simulate a radial turbine in Turbomachinery CFD. In the second part, there will be a Q&A session dedicated to your questions and my answers. Feel free to put your questions below to the comments, or there is a special Q&A window where you can put your questions, and I will answer them later in this webinar. I'm gonna be quite general, especially at the beginning of this webinar, and later on I will go more in details, and also feel free to put your questions about any details. It's your time. I'm here to tell you everything what you would like to know. Okay, I guess it's time to share my screen now. So I'm going to share my screen, which is clicking here, share my screen. Okay, so I believe you can see what I can see, which is a ParaView window with Turbomachinery CFD plugins. And okay, so let me start with a brief description. What is Turbomachinery CFD? So Turbomachinery CFD is a unique software based on OpenFOAM, and it was designed for CFD simulations of all rotating machinery, such as pumps, fans, compressors, turbines, water turbines, both radial and axial machines, both compressible and incompressible flows. Turbomachinery CFD is complete CFD workflow that covers all the steps from the pre-processing over the simulation to the very detailed post-processing of the results, either in like visual post-processing or like reporting of integral values. So this is what you can see now. It's the Turbomachinery CFD interface. This is how it looks like. But before we come here to work from here, let me put just a quick review of Turbomachinery CFD unique value proposal. So I will go to my web browser right now, and I'm gonna visit CFD Support's Turbomachinery CFD web page. So I can say I'd like to Google Turbomachinery CFD, and very at the top you can see Turbomachinery CFD. I click on it. So Turbomachinery CFD. This is the web page. This is the main website of Turbomachinery CFD. Here you can find the most important information. Let me put just a quick points of unique value. So number one is Turbomachinery CFD has no licensing policy, which means our clients can keep Turbomachinery CFD forever, and they can use it for unlimited number of users, jobs, or cores. And of course, that gives their investment in Turbomachinery CFD a permanent value. Number two is Turbomachinery CFD is fully automated, which means all the workflow from the start to the final results can be run by a single command or a single click in graphical interface. The test case setup and the machine geometry are read from a single file, and all the processes can be done automatically. So number three is Turbomachinery CFD is open source. That makes it easily customizable, and it's easy to modify it to your own purposes, to your own workflow, what are used to do in your workplace, in your company. And number four would be the real machines, the real tutorials are included. So the user has no doubts about the best practice settings. There are real machines already that are already preset, and basically the user can come, just replace the surface geometry and modify the physics and the settings and run his simulation. So it's ready to use. It was number four, and there are many other benefits of using Turbomachinery CFD. I'm not going to go for all of them right now. Feel free to contact me. I will gladly describe you all the details. Perhaps the most important information from today's webinar is all the information is available online, right? So you can go to our website and you can find all the information here. So basically you can forget everything from today's webinar, but the last point, the point is all the information is available online. That's pretty interesting. So you can tell your friend, and he would be able to simulate his first Turbomachinery CFD simulations this afternoon. So it's pretty easy, and I'm here to show you how to do that. So Turbomachinery CFD is available both for Linux and Windows. The workflows are exactly the same. Turbomachinery CFD is transparent, so the trial version is available for free for 1 month period, and anybody can download it, anybody can test it, and afterwards he or she can decide to buy or not. So what is important, clients always have the full and complete information before they take any decision. So it's very transparent. So in the download section in our website of CFD support, in the download, you can download Turbomachinery CFD or some other software based on OpenFOAM, but this is about Turbomachinery CFD. So in the download software section, you can click, for example, Turbomachinery CFD demo for a Windows, and you can download directly the exe file with the full installation. Right? Okay, there's a process. You have to first install, especially in Windows, you have to first install OpenFOAM for Windows and then Turbomachinery CFD demo. But pretty easy. There's also step-by-step PDF where you have described everything step by step. So everything is described in this PDF, which is available online. This is quite important. So if you follow these steps, you will easily install Turbomachinery CFD and run your first cases. And this is what's important at the beginning. Okay, maybe it's time to okay, so all the information is available online. You can in Turbomachinery CFD webpage, you can click, for example, Turbomachinery CFD workflow, where you can read more details. What are Turbomachinery CFD inputs? What are the outputs? Which format? How to run your first cases? So this is the information in the beginning, and all you need to do is to download the software, or if you're interested to try it, you can download the demo. You can also in section download cases, you can download one of 7 tutorials for Turbomachinery CFD, like axial fan, pump, radial fan, Francis turbine, radial turbine, like from turbocharger, radial compressor from turbocharger, or Kaplan turbine, and you can run them just directly. It's pretty straightforward. In today's webinar, we're gonna work with radial turbine. So again, you can quite easily. You can give your email. You can download it and run it. So in references, you can find Radial turbine like website where you can see how the process looks like, what's going on, what happens in the background. So it's the surface geometry and the configuration is being read by Turbomachinery CFD, and it's loaded. Then it's automatically, the mesh is created automatically. Then the simulation is run, and of course then the results are evaluated. So it's pretty simple. You can see background and physics of this case in this website, which is in references on our website of CFD support. So that's the physical background for today's case. Yeah, so I'll go back to my case today. So basically, the Turbomachinery CFD workflow is fully served from a graphical interface, GUI. The graphical interface of Turbomachinery CFD is ParaView. You can also work from terminal, but most of people prefer to work from the graphical interface. But of course, the decision is always up to you. In today's webinar, I'm going to work from Windows system. The Linux workflow is very the same as in Windows. Again, the choice is up to the user. Let's take a look at the Radial turbine tutorial. So you can download it from the website, and you can load it pretty easily. Each tutorial has its configuration file, which is called radial turbine.tcfd. .tcfd is a special extension for Turbomachinery CFD, and it's pretty simple. It's plain text file. I can show you. It's pretty simple, where you specify there, or you can specify there how many all the parameters. But of course, you can put them also in the graphical interface, right? But the very first step in your work would be opening the configuration file in the ParaView, which brings you here. And here you can open and close windows and work, use all those managers and everything. So which I'm gonna show you now. So there's a radial turbine, right? And usually the aim of the radial turbine designer is hunting for pressure ratio, flow rates, torques, and of course the efficiency. So each Turbomachinery CFD simulation case has its inputs, and these are basically the surface geometry, which is 3D geometry loaded from your some design tool or from your CAD, for example. It's very standard, very simple .stl, so it's stereolithography format, very standard. All of CAD systems can export this surface geometry. It's like 2D mesh in 3D. It's pretty simple. Perhaps I can show you. Yeah, so it's such a simple thing. So it's the surface. Yeah, maybe I should also explain. There are a couple of components. So this particular test case has 4 components, which is the inlet tube, the impeller, the gate vane, and the spiral, right? And there are 4 components here, and each of them is waterproof. It's closed. So, for example, the outlet, because the inlet, right, is the spiral. The outlet is the outlet tube, the simple tube. So maybe I can show you. I can load this particular parts, these STL files. I can load them this way. I can switch off the components. I can switch on the the outlet tube. So this is the outlet tube. Maybe I should make it white. Yeah, all of these components. You can see there's the inlet of the outlet tube. There's the outlet of the outlet tube, and there's the wall. And maybe I should also show you an ideal setup is waterproof, of course. Any component has to be waterproof, and also it's strongly recommended to be fitting vertex to vertex, which means these, you can see this edge at the outlet. You can see the vertices are fitting perfectly. So this face has common vertices with the other face. So that means vertex to vertex fitting. So that's the component, right? So I have 4 components. I'll go back to my complete model, which are 4 components, right? Which are waterproof and ideally vertex to vertex fitting. So I think that's enough for my 3D data. And then the other input is the configuration, right? So it's in the settings. You can write everything down here. So you specify here all those parameters of the fluid flow, of like physical settings, geometry parameters, mesh settings, boundary conditions, simulation settings, all of them. So later we can go one by one, but I will try not to go too much in detail. So really, there's the settings, the physical settings, and or the simulation settings. There's the configuration and the surface model. That's the input, right? And once you are satisfied with your input, you use Turbomachinery CFD Manager, which is a special filter here. It's the icon with the arrows, or you can find it in menu. You use Manager, which give you a special toolbar where you can write the case, you can create the mesh, you can run the simulation, you can skip between points, you can skip between speed lines, you can abort the simulation, you can anytime during the simulation, you can update the report, which is important. And I will speak about the report in a minute. So you can update the current results, you can view them immediately here in ParaView, and you can take the decisions even before the simulation is finished. Okay, so here you run the simulation. It takes some time, so I'm not gonna do all those steps. What is important, it's possible to run everything in one. You can click this run all, and all the steps are done automatically. So really, a single click can allow you to do everything automatically. Then you can watch the results, you can stop the simulations, go back, and this iterative process is very effective and bring you so much results. Okay. Yeah, which brings me, once the simulation is done, or any time during the simulation, is very useful thing is the report. So every single simulation has its report. So once you run the simulation, you have the report. Here in graphical interface, it's in .html format, so it's ready for your web browser. Anytime you can go to your web browser and directly view on any device. You can view the results. So maybe I should comment just a little bit. I will give me a second. I will take a look whether the seminar, the webinar is running. Okay, it's running. So okay, I'll go back to the to my report, and I will just comment briefly. There are multiple speed lines where you can see what's the flow rate against the efficiency, what's the flow rate against the total pressure difference or pressure ratio. There are many interesting details about the mesh, how many cells, how many points were simulated for this speed line, Y plus, number of processors, etc., etc. Also the efficiency, how it was developing in time, how it was standing against the flow rate. The same for the torque, how it is developing in time and how it looks against the flow rate. And the same for total pressure difference. The same for total pressure per interfaces. So here, this is important. Here you can see how your total pressure is developing over all the interfaces, which shows you how the total pressure is basically spent when flowing through your machine. So we have 4 components. Each component has its inlet and outlet. So altogether we have 8. So it's inlet outlet times 4. So it's 2 times 4. We have 8 interfaces, and you can see how the total pressure is being spent on your in your machine, right? So there's the inlet, there's the vane gate, there's the impeller, and then the simple tube, the outlet, for example. You can see what's the velocity at every interface, again, how it's developing in time and how it's standing against the flow rate. And you can also see what are the circumferential and meridional angles in average at every interface. Again, very important properties for the machine designer, because you have immediately all the information all the time. So very useful. Anytime during the simulation, you can click update. You can click update your report, and the report is updated, and you see immediately the results. Yeah. So then the very important thing, of course, is the to see your results, to make some visual post-processing of your results. So for this we have created special feature, special set of tools, which is called TurboBlade Post. It's part of Turbomachinery CFD, of course, and it help you to compute, for example, the average of all your quantities in a meridional view. That's important. So maybe I can show you that's the meridian of the the impeller and the outlet tube, and you can do the averages of all your quantities. That's quite important. And also what you can do is blade to blade view in any level between hub and shroud, and you can transform your Cartesian vectors, right, to the view where you can see any level between Hub and Shroud, and of course relative velocities and vectors and yeah. Maybe I should stop here. I will take a look whether you have any questions. So I'm going to, yeah. So I'm back here, and I'm going to go for your questions now. Okay, there's a Q&A. I can't see any questions, so I will take a look into my email. Okay, not here, and also I will take a look into the webinar. Okay, there's no question here. So okay, so I believe you get the point. So which brings me to the finish. So I think you got the point. All the information is available online. We are here for you. We think we have great software. We have to tell the world out loud. It's here. It's coming. It's great software for turbomachinery. It's affordable for. We believe it's affordable for most of those CFD engineers and CFD people. And okay, so thank you for watching. So we just stay in touch. We are here for you. So feel free to contact us, and we will do our best to show you, to prove you ourselves, our software, and we believe it's something big. So okay, thank you for your time, and bye bye. Okay, yeah.